This is Krishna.
Bertrand joins. Welcome everyone. Bertrand Portier is here from IBM and welcome to lab 3 for the openIDL test drive. So today we are going to do what's called the virtually guided onboarding, and today is all about blockchain. So you will get hands-on and instructions on how to set up your blockchain environment and connect to the openIDL network. So Krishna and the team are going to take you through these steps, but before we do that, we are going to take a step back and I will describe to you some of the critical Hyperledger Fabric concepts and terminology so that you can follow along when we talk about these steps. And as always, please feel free to ask questions in the Zoom meeting, and or if you're listening to the recording, we have the openIDL test drive landing page with access to resources, etc. So let's just get started. Let me share my quick presentation, and then Krishna, I will hand it over to you. Just making sure, Krishna, you guys can hear me, okay?
Yes, I can hear you, Bertrand. I guess you can hear me.
Yes, very good, yes.
Yep.
So let me just share this. Share. And then go into full screens. Okay, so just a few concepts on Hyperledger Fabric. So Hyperledger Fabric is the technology that we are using for openIDL. It's an open source technology under the Linux Foundation. So Hyperledger has a number of blockchain technologies, and it sits under the Hyperledger Foundation and has the Linux Foundation, and it has all of the open source governance and community procedures and practices in place so that the code for Hyperledger Fabric, the code for blockchain that we all need to trust, can actually be trusted. So it's not just developed by one company, it's developed by the community and in an open and transparent manner. So as we go through today, you will hear a number of terms used again and again. For example, a peer, the ledger, channels, policies, smart contracts, or chain code, etc. So what I want to do is just go over these very quickly so that you can follow along. So on this page here, we start to introduce some of these concepts. So there is one organization that is part of a blockchain network. That organization has P1 and P2. These are peers, right? And I will explain more what that means. But these are, if you like, the blockchain nodes or the peers where the ledger is residing for your organization. And then we have an S on top of the peers. This is for smart contract. And we call smart contracts chain code. So that's the Hyperledger Fabric name for that, right? And then so you see the L that describes the ledger. So each of the peers has a copy of the ledger for what they have access to. And C here is a channel, and I'll show you what that means. It provides a way to support privacy, so that only you only have access to what you're allowed to see, and not necessarily things that are on the network but not private to you. A is an application, CA is a certificate authority, because we are a permission network, so we always need to prove our identity as we go through this. And then the ordering service is a component that we have that is part of the blockchain network that is responsible for creating the nodes, creating the blocks, the blocks that go and that are chained together, right? So for us in permission blockchain, and specifically Hyperledger Fabric, we don't need to do mining or proof of work or anything like that, right? What we do, we have a different consensus mechanism based on endorsements, and the ordering service is responsible for creating the blocks. So if you look a little bit more details here, so what's happening we have like a very simplified network in blue here on the right-hand side here, right? And then it only has one peer from one organization and then one ordering service for the network. And we see that outside of the network on the left, we have the application. And the application is basically a Hyperledger Fabric client. It has the Hyperledger Fabric SDK embedded in it, and it can talk and communicate with different components that are part of the blockchain network, the Fabric network. Membership services are capabilities that are part of Fabric to allow an organization to manage identities, right? And here we have a certificate authority that each organization can use as part of the network implementation, or the ability to use an existing certificate authority that lives outside of the network. If we look a little bit more detail here on the peer, and you look at all of the different things that are going to happen, that are going to be part of the Fabric peer, the one thing to understand here is that at a minimum, if you want to be a peer, you need to be a committer. And by being a committer means that you have a copy of the ledger, right? You have the ledger here on the peer. Some peers are also endorsers, and that means that they participate in the consensus mechanism, and they have to endorse transactions before they are committed to the ledger. And then chain code for us is just the smart contracts. This is the application logic that runs on top of the ledger. And then I'll come back to this and show you how it's used. One important aspect as well is that Fabric peers can emit events that others can subscribe to even outside of the blockchain network. Now, if we look at how applications interact with the ledger, really important to understand that we have to go through smart contracts, right? If we want to read the ledger, if we want to make update to the ledger, etc., because it is blockchain, then we have to go through the smart contract layer. And that is a critical aspect of blockchain. And remember that for us, when we say chain code, what we mean is smart contract today. And then with Fabric, if you look at what we are talking about, we are a blockchain. So we have both the world state that is there on the ledger, as well as the chain of blocks. And the chain of blocks is going to have a full history for all of the transactions that ever happened on that network, all the way back to when the network was started, all the way back to the Genesis block. So we have linked blocks here that make up the blockchain. So that's why it's a blockchain and not just a distributed ledger. Okay, so if we look a little bit more at what happens on the peer, right? So a peer is going to be connected on the network by channels. It's going to be part of a number of channels. And then you will see how we set up those channels when we go through the steps later, right? It also has the chain code that sits on the peer here. So it will have a number of different smart contracts for the different business logic that we want to have as part of the network. It has the local member service provider to manage identities, and the blockchain and the world state as the ledger. And then you take a number of different organizations that each have their own peers with everything we saw before, and you connect them into a network. So here we have a network that has 3 organizations. These 3 organizations each have their own peers, and they are connected via what's called a channel. So a channel is a way for participants on the network to provide access to data as part of the blockchain network. So they will have these participants on the same channel. We have a a distributed copy of the ledger that is specific to that channel. So in our example, for example, you participate in a data call, you're an insurance carrier, and you have a channel that is open between you as the insurance carrier and AAIS as the advisory organization. No one else is going to see that ledger. That ledger is going to be private to you and AAIS only. And then I will continue here. So we are a permissioned blockchain, and that gives us a lot of benefits, and we have to because of the highly regulated industry that we are living in. And blockchain for business for us at IBM is always permissioned blockchain, right? There's no anonymous blockchain here. And because of that, right, Fabric is also a permissioned blockchain. It has capabilities to support what we call identities. So each of the organizations is going to have its own identity, and as part of the environment for each of these organizations, there are components that support those certificates. And for us, it's based on X509 certificates, and each of the organizations is going to have a certificate authority. So here you see CA1 for org1, CA2, CA3, etc. Even the ordering service has its own identity and certificate authority. Right? And then the applications, same thing, need to sign when they invoke blockchain transactions. Client applications also have to sign. So anything that happens on the network, you need to prove your identity. You need to sign your transactions. And based off of who you are, you will have different rights, different access rights to deal with the ledger. So just here is an example where we use channels. So we have one network here in blue, in the light blue box. And on that network, we have 4 peers, right? We have endorser 0, 1, 2, and 3. So we have 4 different peers here. And you can see that peer 0 and E0 and E3 are connected to the red channel, right? And they have specific chain codes deployed onto them, which is chain code Y and Z. What that means is that peers 1 and 2 that are also part of the same network do not have visibility onto what's happening on the red channel. So they are not part of the red channel. They don't see any of that. And then peers E1, E2, and E3, right, are part of the blue channel. So you see there is a blue ledger here. There's a blue blockchain. So each one of these peers has a copy of the blue ledger, which is related to smart contracts A and B. Okay. But peer 0 here does not have access, does not see that ledger. Right? And you see a particular case where E3 is a member of both the red channel and the blue channel. So they will have 2 ledgers for these 2 channels here on their peer. The endorsement policies, we don't need to go very deep into that, but endorsement policies are how we do consensus, how we reach an agreement on the validity of transactions. And for us, endorsement policies are related to specific smart contracts. So each of the smart contracts, A, B, Y, and Z, are going to have their own endorsement policies that are going to define who needs to endorse specific transactions for these smart contracts A, B, Y, and Z. So that's just how we do it, but we don't need to go in details for today. And then the applications are in white. They're outside of the network, but they're able to interact with the network on specific channels based on who they are. One last thing, and this is a little bit of a more advanced concept, but we use that a lot in openIDL to support privacy and to provide access to data. Is what's called a private data collection. So a private data collection is a Hyperledger Fabric concept, and you can think of it as a side database. So this is not a data that goes on the immutable chain and that's going to stay on the chain forever. This is more like an off-chain side database that can be used we still want to use the blockchain gossip protocol to transmit data. So we still use those protocols to transmit data between different peers. But this is really a private state, private data that is not going to go on that, on that specific channel's blockchain. Right? The actual data does not go on chain. The actual data just stays in the private data collection and can be transmitted to other peers that have access to that private data collection, but the data does not go on the immutable chain. And really important because we don't want to have too much data on chain, and we want to be able to, to like at a high level, like we never put too much data on chain. But here we have a mechanism to transmit data over the blockchain protocols without putting data on the immutable chain. So that's how we use private data collections, and the team will go into more detail on how that is done when we do the data call, etc. And this is the last slide, and this is just to introduce the IBM blockchain platform. The IBM blockchain platform is what you're going to see live and demoed, and what you're going to use if you're standing up your environment, your peer, your smart contract, connected to the network, etc., etc. We at IBM created that offering to support multi-party business networks, so multi-party blockchain networks, where we know of the challenges with having separate legal entities having to work together and being connected at the same blockchain network. And what we did is we took the Hyperledger Fabric code base and we packaged it as an IBM offering, and around it we added developer tools for developer productivities as part of the SDK on a Visual Studio Code, VS Code, as well as operator tool that you see here on the right, which is basically a console that allows for the governance and the management of the network, right? Things like inviting participants to the network, managing what's happening on the network, etc., etc. And then what it does in terms of the code, it simply uses Hyperledger Fabric and Hyperledger Fabric APIs. So you can take the code that you develop here on the IBM blockchain platform, and you can run it on a different Hyperledger Fabric offering if you want to. And the other thing that's important to realize here is that the IBM blockchain platform offering can run on your cloud of choice. Right? So, and again, we know how important that is for openIDL, where each of the participants may have a different cloud service providers that's been approved. So with that said, that was a very, very quick, like firehose type introduction to terminology. I will look in the Q&A if we have any questions live. Don't worry too much if this is abstract at this point, because it is, and we are going to make it very concrete by going through the setup. So let me just see here, let me stop sharing and see if we have any live Q&A, live questions. Okay, so we have no open questions at this point. Krishna, before we move to the next session, did you have any specific comments you wanted to make on the Fabric terminology? One of the specific items, maybe?
No, Bertrand, you pretty much covered it, all the aspects of it, all the components end to end. Yeah.
Okay, very good. So now with that said, now I'm going to hand it over to you, Krishna, to talk about the onboarding.
Sure. Let me share my screen and see how it works.
Maybe Krishna, you can introduce yourself and the team because I think it's the first time you guys are presenting as part of the test drive. So we can see.
Okay, you can see my screen, right?
Catalina, we see the island, not the contents.
Oh, not the contents. Can you see my screen now?
Only the background.
Yeah, I guess I need to just log in one more time. Give me a quick second.
Okay. So Krishna is the lead solution architect from IBM on the on openIDL, and so he's leading the development of all of the different components from data aspects, blockchain aspects, the different environments that we have to do development, staging, production, onboarding, etc. And I will let Krishna introduce his team when he's ready.
All right, how about now? Can you see?
I see, yes, you have a web browser with Zoom.
Yeah.
IBM blockchain platform.
Excellent. So, yeah, all right. Good morning, everyone. This is Krishna Allada, and I work for IBM blockchain services team and work with Partrin and on the AAIS openIDL platform. I'm the architect for it. And we have James and Rao also part of the project from the development perspective. So with that, I'll start with what we are trying to do. Today, we're going to walk through on how to set up a blockchain node on IBM Cloud and integrate that with the openIDL blockchain network. Before going into the live walkthrough on the steps, so by the way, these are all the steps that we are going to do. And before getting into the steps to stand up the node, I would like to give a high-level view on what the activities look like and how they are related. So with that, if we see the step one, we are going to do is like we will start with creating a Kubernetes cluster and then create an IBP service instance. Then the created IBP service will then be provisioned on top of a Kubernetes cluster that we created. And we're going to, in order for a blockchain node to connect to your network, we should create certain identities that are required. And those identities are created using CA. For that purpose, we are required, in order to create the identities, we require a CA, as Barton was also mentioning in his presentation on the Fabric components. And we're going to set up, using those identities, we are going to create the Msp definition. And we are going to export that Msp definition and import that onto the existing openIDL blockchain network. And then, we will set up the orderer service. Now we will add the definition to the orderer service and we will export that. And we again import that back into the IBP instance that we created so that they are tied together. And by using the Msp definition that we have actually created, and the orderer with the definition, we will create a channel, carrier channel, and we will use the Msp definition and organization Msp definitions to it in order to create the channel. So once we do that, if you notice, there are a couple of highlighted the dotted lines as well as strong lines, means they are anchor pairs and the definition being used, and the necessary identities are being used. And then the peer will also be connected to the channel on whatever the newly created channel for this carrier demo purpose. And we already have a default channel, and we will try to join the peer that we have created on this IBP platform to the default channel. And then we're going to set up the chain code, the smart contracts on to the respective channels, both on the carrier channel that we have created along with the default channel that we joined. And we install them and we instantiate along with the private data collections. So that said, yeah, if there are any questions, we'll take those. If not, we can go through the live steps to create the node and integrate that with openIDL network now. And yeah, please stop us if you have any questions while we are going through these steps. So I'll stop this full screen and I'll make the split screen presentation so that we can follow the steps one by one. So as I said, we are going to create a Kubernetes service on the IBM Cloud account. We're going to select the Kubernetes service, and we can see all the various options around the Kubernetes service, and hit create. We're going to select Kubernetes with classic infrastructure. I will change the name with KAS. I kept industry test drive cluster. With the resource group, I left with the default. For this purpose, I am selecting single zone, but we can select multi-zone for the production environment. So we're going to select 8x32 and worker nodes. I'll leave it as 3 worker nodes and create cluster. This will take around half an hour or so. So in benefit of time, what we did is like it is still processing. You can see that. So in benefit of time, we have created a cluster, similar cluster that I did walk through now. So we will go and use this cluster. And yeah, it has a similar configuration. And we will now go ahead and create the IBP. In order to do that, we have to go back to the catalog and select blockchain platform. Standard, and we'll give a name as IAS demo, ITD, IBP. I'll leave the resource group for now, but we can actually pick the resource group, and we'll go ahead and create. So this will actually bring up once we create the instance, and we can go, it directly took us here, but we can actually navigate back from the resource list. This is the one we have created. And we came again to the same area where we can see this. And as we have already created a cluster, we can say I have a cluster. If not, we can go from here as well. Yeah, the split. Yeah, once again, the split screen is not working well here. This is the one that we just created. It is still provisioning. That's why it has a star. But in benefit of time, what we are going to do is like we are going to use one of the clusters that I created earlier. And this is the one, and we'll hit deploy cluster. It's deploying. Once it is ready, what we'll do is like we'll create the certificate authority. It takes like a couple of seconds here. It's ready. We can click launch the IBM blockchain platform. By doing so, we will actually get into a screen something like this. Let me do that. And this gives us the blockchain platform instance on IBM Cloud. Let's get started. And if you notice, we are landed onto the nodes tab, and IBP has various tabs with the nodes. I'll just quickly go through all the tabs and come back to this tab. And this is the channels related tab where we create the channels. And this tab is the smart contracts tab where we have to deploy, use it for deploying the smart contracts, install, instantiate, and wallets to add the identities and to create Msp definitions. And other users are now giving access to the instance to participate to this network and other related settings. So I'll go back to the nodes tab in order to create the CA. So what we'll do is like we'll click the add certificate authority and create an IBM Cloud certificate authority, and we have to select that. Click next. So what we have to do is like provide the display name. So I will pick demo carrier CA. This is the CA identity, CA admin user identity. So for that, I'm going to give admin and admin PW. And we can pick this resource allocation so that we can actually configure them. I'll check this so that we can see how it looks like. We can actually configure and increase the CPU compute related things, memory and storage. But for now, we are not going to change, and I'll just keep the default and click next. And let's verify once whether the things are in right configurations, and then click add certificate authority. It is creating. Yep, it got successfully created. We can see that in the certificate authority area. So now what we have to do is now we have to select that and associate that admin user to the certificate authority. It's taking a little longer time. Yeah, we got the page loaded, and now we will associate the identity. We'll choose the enroll ID and provide the admin that we have created, the same password that we have actually used, admin PW, and we'll use demo carrier CA admin without cap, and we'll click associate identity, it then make part of it. While it is processing, we can actually see the cluster. And this is the cluster being used, Kubernetes cluster. And this is the namespace where the IBP related components are deployed. I have to select that in case if you want to see the details on what's really happening at the cluster level and see how many pods and all the details. I'll go back here. Yeah, it has a problem. I'll go ahead and recreate one more time. Yep, it has finished this. So I'll go back and come, but it is, we can actually stay on here and we can click register user to create the other users. So I'll click the register user to create different types of other users in order to make this network participate. So I'll create with the name ID as carrier admin, and I'll use carrier admin PW. And we have to select client type, and this is the user where it participates from the client transactions as well, in the sense like from the SDK that Bartran showed, and the necessary transactions need to be signed and all that happens from this client user, and also this user administrate the organization level related configurations as well. So now we leave the default as use root affiliation, sorry, and we can leave the maximum enrollment as as is, no need to give, so that it allows maximum enrollments. If not, we can specify, and we can add additional attributes in case if we want to use any access based attribute based access control. But for this purpose, we can leave that and click register user. This has created a new user. We have to create one more user similar to that with the peer as the type. So we'll create with peer 0 and carrier, and we can use the same one with PW. And now we have to select type as peer, and we can leave the default use root affiliation and maximum enrollment. And let's create next, and we can leave the attributes as default, register user. Now that will make a new user created there. So now we will go ahead and create the Msp definition. So we'll move and navigate to organizations tab. And create Msp definition. We'll use display name for this as demo carrier Msp, and the actual Msp ID small case as demo carrier Msp as the actual ID. And we have to pick up the root certificate authority details as that we have created, and we can leave all these as default values. And then instead of SEA admin, we use the other carrier admin that we have created for this Msp definition, and we have to put the password. And identity name we will keep as demo carrier Msp admin without gap. And yeah, important topic is like we have to generate this and store it in our local machine or wherever it is, because IBP doesn't store anywhere the certificates for the organization on the instance. So whenever we have to connect to this, we have to use those credentials. So usually what happens is, like, once we do this create Msp definition, the browser will cache that and will be used. If we clean it, it will be gone, and we have to use whatever we have generated to reconnect back into the IBP instance. That said, so I'll generate and we need to export it. So that got downloaded, but let's quickly check. This is the MSP credentials that we have downloaded. And now I will go ahead and hit create Msp definition. Right, it got created. And now we'll go and create the peer. So in order to do that, we have to go back to the Nodes tab and click Add Peer, and create an IBM Cloud peer. Select that, click Next, and we'll give the peer display name as Demo Carrier Peer 0, and state database collection selection. And we're not using external CA configuration for this purpose. We have used the CA that comes with the IBP. And select resource allocation. Again, this is to allow if we want to configure the necessary compute power for the IBP instance for this peer. So let me click Next, and we have to select state database. It's the world state database. So for this purpose, we are going to use CouchDB. It has rich query capability instead of level DB. So for that purpose, we're going to use CouchDB, and click Next. And we will leave the certificate authority as demo carrier CA that we have created. We only have one here. And instead of admin, we will select peer 0 carrier user, peer enroll ID, and we have to put the password. Okay, and the definition that we have created, that is demo carrier MSP, and we can leave the TLS as CSR host name. This is for the communication, secure communication. If we have a specific domain configured, if not, it uses the defaults. So I'll click Next, and this is for the resource allocation. We can actually leave the defaults. You can see the configuration settings, and let me click Next, and we have to choose existing identity and select as MSP admin, demo carrier MSP admin, and click Next. Check for all the details that we have configured, and click Add Peer. That will actually bring the peer. And if we wanted to see here, we can refresh the dashboard of the Kubernetes. And if you notice, the peer is getting created. It takes a little bit of a time to get the PVC, persistent volume claims and all, but we'll move on because we have to create and configure other things while it processes those. So now we have created peer, and now what we have to do is like we have to go ahead and export the organization MSP definition. Go to MSP, sorry, organizations, and select the MSP. And we have settings, export, delete. We'll click the export, which actually downloads the file. So let me share my screen. So this is the one. We will use these files in order to connect to the openIDL network. So this got downloaded or exported. So what we have to do is we have to import the downloaded MSP definition onto the openIDL network. For doing that, I have to log into openIDL network. So not the instance that we are using. So I have a different instance here. So let me refresh. So we'll navigate here to the organizations. And import MSP definition. And we need to select the file that we have downloaded, exported from other side. And we will get the demo carrier MSP that we have created on carrier IBP instance. And we'll go ahead and import MSP definition. If you notice that I have actually got the MSP definition here, successfully imported. And now what we will do is like, add this carrier organization MSP into the orderer. So in order to do that, we have to navigate to Nodes tab and scroll down. Under ordering service, we have to click orderer. And we need to add under the consortium members. So how do we do that? We have to add organization and clicking existing MSP ID. And we are going to select the demo carrier MSP that we have actually imported just now. And click add organization. That will actually add into the ordering service. And now what we have to do is we have to export this orderer and we have to import back into the carrier's side of it. So how do we do that? We actually go back into the orderer. And again, we have settings, export and delete, and we will click the export and save to the local. And we will get that file. And now we will go back onto the carrier's IBP instance. and import. So how do we do that? Navigate to Nodes tab. Under ordering services, add ordering service. So now we have to select import an existing ordering service. Click next and add file. And I'm going to select the one that we have actually downloaded from openIDL network. Choose that, and by default it selects with the orderer, the one we have there, and next, and we have to choose the existing identity, and from the selection of the identity we have to select demo carrier MSP admin. And add ordering service. If you notice, it was not there, it got now added. It's just a definition. It's not the actual orderer who sits on this instance, but it's the definition in order to connect and get the transactions passed along. So now what we have to do is, like, we have to create the channels. So between carrier and openIDL network. For that, what we have to do is we have to go back again onto the AAIS openIDL instance and create a bilateral channel. So we'll navigate here to channels. Now we'll click the create channel. Channel details we'll put as AAIS demo carrier. That's the channel name. And we have to select orderer as ordering service that is available. And scroll down and we have to select AAIS Analytics MSP, add, and similarly we have to select, there are various MSP definitions, but we are only joining to this channel two organizations, that is AAIS Analytics we just added, and the demo carrier MSP that we just created. So for now, we will put both organization as operators, and we have to define the channel update policy. We'll pick either of it, so one out of two. We have to scroll down and leave the default for advanced channel configuration. And in the creator organization, we'll select as AAIS Analytics MSP because we're doing from here, and we'll select as the definition or the identity for that as AAIS Analytics MSP admin. And yeah, we can create the channel by this. It creates a bilateral channel between AAIS Analytics node to demo carrier node. It got successfully created. So this is the new channel that got created. So the next step is we have to join the channel. By selecting the existing one. Now we will not make this as anchor peer. We will uncheck that, and we will make the anchor peer on IBP of carrier side. So when we join that from that side of it, for now, we can go ahead and click join channel. Once again. Yeah, we didn't select that, that's why. So what we have done is like we created a channel to get analytics node as well as the demo carrier node to join and participate. And we made the channel to join AAIS analytics formally, and we made this. And we'll move on now on carrier side to join the channel. So we'll go to channels. We'll click join channel. And we'll select orderer. That is the only ordering service currently we have. Click next. And we have to put the same channel name, AAIS demo carrier channel, and click next. And now we'll make this as an anchor peer and select this. If not, it doesn't allow. And join channel. So by this we have made, we created the channel, and we joined AAIS Analytics node to join into the channel on openIDL network. And now on this side, we have joined demo carrier node also to participate in this AAIS demo carrier channel. So now this is a bilateral, two organizations are participating in this channel. Okay, so now what we have to do is we have to join the default channel back from on AAIS. Navigate to orderer. Sorry. And click settings, and we'll come to this, and we'll leave the default here, and we need to add the MSP demo carrier MSP into the default channel, so that default demo carrier node can also participate in default channel. So default channel on openIDL will be used for all the data call related activity, and for the carrier to like and consent and to list all the data call related details. So for that purpose, we have to add the demo carrier to participate in the default channel. And for now, I'll make this also as operator. And we have to select the policy as 1 out of 4. And channel updater will still select as AAIS carriers MSP, because that owns this default. And we'll select the same MSP as carriers MSP admin, and we'll click send proposal. That way it formally adds the demo carrier Msp definition into default channel. So similar activity, we have to do it from carrier side. So I'll switch back again. So we'll navigate to channels. We are right there, and join channel. We'll select orderer. That's the only orderer. Next, and we have to give default channel as the channel name without space. And we have to select the peer that we are going to get this participated, and we will not make as anchor peer for this node on default channel. You have to select that and hit join channel. So with this default, the demo carrier node also joined into default channel with all other existing organizations or nodes. Now we should see 2 channels, one demo carrier channel and default channel. It's still performing. Well, we can go to the cube cluster. So if you notice, yeah, we got the nodes created, and we got the peer, we got pods, and even we got services and all. Right. So let me check. Yeah, it got created. Somehow it didn't refresh immediately. So we'll now go ahead and install chain code on the default channel. So to do that, we have to navigate to the smart contracts and click smart contract or the chain code. And we have to upload the package. The package is usually as a CDS file. And we have to, I already have that. And this is the default chain code, which is packaged as a CDS file. We have to choose that and verify the version, and need to install it. So once it is successfully installed, we should be able to see this. And we need not to initialize, instantiate this particular chain code or smart contract again, because we have joined to the existing default channel, which was already instantiated by AAIS analytics or carriers node. So that was the reason we need not to do this step. But for demo carrier channel that we have created, and we are going to install a different chain code there, and for that we have to install and instantiate so that it initializes and ready for the chain code to perform on the transactions. So now on carrier side, we are going to install the chain code, as I said, not the default, but now by selecting the other chain code. Earlier we used the default one. Now we are going to use demo carrier related chain code. Select that, check for the versions and install. And we have to install the same chain code, whatever installed here, onto the openIDL network. So if you notice the demo carrier chain code that we have installed, it was not instantiated here, but we will do that from the openIDL network that we have. I'm switching back here. So we'll navigate to smart contracts. We already have a lot of chain codes installed on openIDL network. We're going to add the new smart contract for the bilateral channel that we created, and click install smart contract button, and select the chain code package. So we're going to select this. Default was already installed here, so no need to do that. And yeah, that was selected, and click next. And we are going to make sure that now we are selecting analytics, because that's the node that needs to be connected and need to participate. Sorry, I'm having a little challenge here. So this, once again, yeah, this is the one that we have created. I mean, added. We have to do the instantiate. select the channel and click next. Select, select the members that are going to participate in this, and policy for the endorsement, any of the nodes or the peers that make the endorsement policy to work. Click next. And this is the area where we define the private data collection, the PDCs that Bertrand was showing in his picture. So we need to select the collections. So before doing that, I'll just open how it looks like. This is the collection definition. So what we are putting here is the collection name and the policy and the identities to be participating in it. So, and the role is the member, and MSP ID is the analytics MSP, and role again the member, and the MSP ID that we are going to connect for this is demo carrier MSP. And the policy is one of anyone can make the endorsement and the consent process work, and the other related details. So we'll go back here. And select the collections, open it. And we can leave the arguments as optional, and click instantiate smart contract. And with that, we have to see the newly created got instantiated. Yeah, this is the one, I guess. Yep, this is the channel that we have created as demo carrier, and it got instantiated as well. And with that, it is done. But we'll go quickly and check on this side of it from the demo carrier side. And earlier it was not instantiated, and now because we instantiated from openIDL network, the same channel got connected with the demo carrier here. So it is instantiated. Instantiation can happen on either side of it. So we did it from openIDL network side, and the demo carrier, when we refresh, it automatically picks up that instantiation definition as well. So I just wanted to show you this, and with that, we can go back and see the channel and the blocks real quick, so that the details are coming. So the channel details are like, these are all the channel members on the default, and this is the block history. We should see an identical on the default channel. So the block is 38 height. If we go back here, and go to default channel, we should see the block height as 38. So yeah, default channel got connected. Similarly, we'll verify quickly the demo carrier. Yes, demo carrier channel, and it is of block height 3. The block height 3, we didn't do any transaction at, but the Genesis block as well as the other configuration related details will be automatically added. And even when we instantiate install instantiated, there will be some configuration related transaction happen on that channel. That's the reason we are seeing the block height. So we can go see, there will not be anything Genesis wise. Oops. This is the chain code related instantiation happened. We'll quickly verify demo carrier channel on AAIS instance. And we see the same block height. These two are also connected. With that, we can conclude the steps, but we can take any questions if you have. Or Bertrand, Truman, you want to add anything? Thomas?
Nothing. Excuse me. Sorry about that. No, nothing else to add from our side here. I think it looks fairly, fairly complete in terms of a walkthrough. So.
Yeah, and if we do not have any questions, then we can conclude, I guess. You want to add anything, Thomas, before?
No, like I said, good first walkthrough, and good kind of overview of what the process looks like. So I think we can probably call it good for the day, and then pick up again with the next scheduled lab, if you will.
Okay. All right. Yeah. Thanks a lot, Thomas, and thanks everyone.
All right. Thank you, Krishna.
Thank you. Bye-bye.
Bye.